Okay, let's review. The types of intrusion detection systems are host-based, network, and distributed. The host, of course, only sees those packets flowing in and out of it, and usually that will employ some sort of integrity verifier like a tripwire, etc. TCP wrappers is sort of what we would consider a lightweight HIDS, providing the wrapping of TCP services. It doesn't by itself provide any signature verification, but it is very functional what it does. Network-based IDSs, of course, put the NIC into promiscuous mode, and they watch the traffic flowing by them on the network. They try and inspect all that traffic, and match it either to a signature or try to detect some kind of anomaly. Distributed IDSs are a mixture of both of the two, and they're the popular and hot topic these days in IDS. Anomaly-based IDS must be trained, then will alert when anomalies are detected. In other words, they must be baselined, and then they will look for differences in behavior. There are statistical, based on measurable network metric, like there are more packets of this type than there are normal, and behavior-based, which are trained to a certain behavior, which means all of a sudden this web server popped out of nowhere, and I'm seeing traffic going to one thing or another, and I'm not used to seeing that traffic flow, so I'm going to send an alert. Okay, Snort. Let's review. The ultimate sniffer. It's a TCP dump replacement, and it can be used just as TCP dump is. You can be used to perform sniffing capabilities, and it's got quite a bit more capabilities than a plain old TCP dump does, and it still supports those Berkeley packet filters. There's also it is also a signature-based IDS, which means it relies on a big database of signatures of known attacks. It will operate as a sniffer, operate as an IDS, and it will write packets in their binary form to either files or databases. There are four basic components: the sniffer decoder, the preprocessor, the detect engine, and the output plugins. And that's where you can control where you want those packets to be sent, or where you want alerts to be sent, and how they are to be sent. It's all configurable by that one snort.conf file. And how to beat IDS, how to attack them. IDS detection techniques include the promiscuous detection techniques that you might use against any sniffer. You can watch for upstream communications, like the sniffer, like the IDS reporting to a console or a management station. You can check for known vulnerabilities in common IDSs. In other words, if you know one exists in a certain area, you can fire a packet out and see if anything breaks. There are also ways to elude IDSs, including the insertion techniques, where you put some packets in between the data that you want to send, and you decrement their TTLs to a low enough TTL so that the IDS will see it, but by the time it actually reaches the host, they've been discarded by routers along the way, leaving only the packets that you want to arrive. You can use evasion techniques, where the IDS sees less than the target host sees. You can use denial of service against the IDS and try to overwhelm it with other traffic and keep it busy, or you can just try and flood its database so that even if you did conduct an attack that was caught, it would be almost impossible to find it amongst the 600,000 or so records. Other eluding tools include FragRouter, which is a fragmentation tool which will purposefully fragment in an odd way packets that will flow past the IDS and then reassemble them on the other side. And of course the great AD mutate, which will mutate the actual code that's the payload of the packet in such a way that it looks different yet executes the same as the original exploit.